In this question type, you'll be given two expressions and told in some way or another that they're identical. You might be told that the two expressions are always equal, that they're equal for all values of x, that they're identical, that they are equivalent. There are a few different phrasings that can be used. And the idea is that if these two expressions are equivalent, they're not just equal for some value of x that makes it work. They're actually identical. They are the same thing. And what that means is that if you get those two expressions in the same format, then you should be able to see that they're identical and that each of the parts will match up. And here are a couple of examples. In this first one, given that this expression, there's our phrasing, is always equal to this expression, what are the possible values of c? Okay, if these two things are always equal, they're identical, so if we get them in the same format, then each of the parts will have to be exactly the same too. This is factored, this is expanded. We can't factor this because we don't know what c is. We can multiply out this side. So we get abx squared plus 2bx minus 4ax minus 8 equal. It says it's always equal, so I can set them equal. Okay, I'm going to do one thing just to maybe make this easier to see format-wise. This whole thing is the x term, and so I'm just going to sort of make it look like a coefficient of x. Okay. Now they're in the same format. They're both in standard form, something x squared, something x, and then a constant. And since we know that these are always equal, we can start matching up parts. An easy one just to check is that minus 8 at the end, minus 8 at the end. Okay, so that looks good. We can also see that abx squared has to be equivalent to 6x squared. And that tells us that ab equals 6. And then we can also see that this coefficient of x has to equal this coefficient of x. And so now we can kind of see the path here, that if we figure out what a and b are, then we can figure out the value of this, and whatever this is, this is. Okay, what else do we have? ab equals 6. We also have, we're told here, a plus b equals 5. And if those two things are true, then we know that a and b have to be 2 and 3. Those are the only things that add to 5 and multiply to 6. Okay, let's throw those in here. So that expression will be 2b minus 4a. That's 6 minus 8 is negative 2. And so we have one value of c. C could equal negative 2. You notice the question says, what are the possible values, plural, of c? The other possibility is that these are backwards, that a is 3 and b is 2. And we have no way to know which is which. So the other possibility here is that b is 2, a is 3, so 4 minus 12 is negative 8. And those are both possible values of c, just because there's that ambiguity about which one of these is which. But the general idea there, and that question would potentially have two answers on the test, or it might have answers that list both of those as possibilities. But the general idea there is, because we know that they're equivalent or equal for all values of x, or identical, whatever the phrasing is, we get them in the same format and we match up the parts. Let's do one more here that looks a little bit different. If this equals that, for all values of x greater than 3, what is the value of m? Let's talk about this part quickly. There's actually only one value of x that doesn't work here. It's when 2x minus 5 equals 0, because then these pieces are undefined. They could say for all values of x does not equal 2.5. They decided to do it a different way, but really this is still saying basically for all values of x, so don't get too thrown off by that. As we did in the last question, we have two things that are identical, but in a different format. What can we do here? Well, we don't want to really do long division when we don't know that. That would be ugly. What we can do is if we multiply all of that and all of that by 2x minus 5, basically we get rid of the denominator. So think like you're working with rational expressions here. Let's just kind of see where we end up. I know from having done these that that's going to be a useful step, but let's just do this and you'll see in a moment where we end up here. Okay, so what we're going to do is multiply everything in here by 2x minus 5 on both sides. Okay, so on the left side, that works out easily, just the 2x minus 5s cancel. Okay, so that's great. On the right side, we've got to multiply this in. X times 2x minus 5 is 2x squared minus 5x. 8 times 2x minus 5 plus 16x minus 40. And then here, the 2x minus 5s cancel, so we get plus 6. Okay, let's go one more line here. 2x squared plus 11x minus m equals 2x squared minus 5x. Sorry, minus 5 plus 16. Yeah, okay, plus 11x. And worth noting here, let's say I got minus 11x here, then clearly something was wrong because we're told that these are equal for all values of x. So the pieces that we know have to match up, just like the minus 8 and the minus 8 matched up here. If you get pieces that don't match up, then something went wrong and you can backtrack and figure out where that happened. And then here we'd get minus 34. Well, that's much easier to see now. They're in the same format, so we can match up the parts. Minus m equals minus 34. So m is 34. That's the idea on these. There's a few ways they can say it, that the expressions are equal for all values of x, or basically all values of x, that they're equivalent, that they're identical, they're always equal. It just means they're the same thing. So you get them in the same format, and you match up each of the parts, and then those have to be identical part by part as well.